it's split into three separate components, three main components. The first component is self-authentication. That's quite an important part. And the problem that solves is if you have a completely decentralized thing, whatever it is, how do you as a person log into it? Because it doesn't exist and it's always changing and all the machines are changing and you don't know whose computer's got what bit of software on it. So how do you log in? So that's the self-authentication component, and it actually is much more simple than it sounds. A simple way to explain it is there's two things. You type in password 1 and it would be this piece of data stored at password 1, and you type in password 2 and that encrypts the piece of data. So that encrypted piece of data goes to wherever password 1 would store it. And when you go back to log in to the system, you ask it for password 1, it gives you the bit of data back, and password 2 decrypts it. And that gives you your cryptographic keys to get access to your data. It also gives you a thing called a data map. So that is the second problem. So there's a mechanism to log in and retrieve information. But the second problem is this is on a network connected to everyone's computer and data on everyone's computer. And you can't store data on people's computers. It's not possible. They would be saying, well, I don't know what you're storing. What is that? It could be something weird. I don't want to. So the second problem is, how do you make your data live on a very hostile network in such a way that nobody knows where it is and it's always available to you when all these people's computers are switching off and on all the time? And that's where the self-encryption thing comes in. And that's a part of the system that's quite interesting because people just hear the word encryption and think, I'll just use AES encryption, and why don't you do it? It doesn't work. So what the self-encryption thing does, it chops up all your data into lots and lots of pieces and throws those pieces out onto the network. But each piece is identified by the digital fingerprint of its contents. So that's a hash. You hear folk talking about hashes. And it's a digital fingerprint. So all these pieces go out, and if you imagine all of these pieces of the jigsaw are spread all about the network. And the clever thing about the self-encryption is if I've got a file and you've got a file and we don't know each other, they'll both create the exact same pieces, but they'll both be encrypted the same way. And people say, oh, that's terrible, people can read your data, and that's a conundrum for people. You can only decrypt a file if you've got the key or if you have the original information. So if you have the original information, you can create chunks and then reverse them. But you don't need to because you've got the original information. So that's one of these things that hurts folks' heads. The two initial issues are how do you log into something that doesn't exist, and that's you just treat it as a big storage thing and you'll store a piece of data and get it back. And the second one is how can you put your information on something that's going to go on everyone's computer? Well, you make it not information, you make it not data. So you pass it through this process of chopping up and encrypt. The encryption part of the self-encrypting files isn't there for encryption. It's only there to make the data irreversible or not compressible, which is as close to random as possible. It's mathematically close to random, but there's no such thing as random. It's like infinity and guarantee and all the rest of it. So that gives us a way to log in and put data on it that's going to be safe. But then the next problem is, what is that thing that you put it on? Is it a server or is it something else? And that's where we said it can't be a server. It can't belong to anyone. And that third part of the puzzle is the network. That's the DHT. You hear people talking about this distributed hash table. And a distributed hash table is a very simple thing. It's every computer's got an address which looks like the hash of the data chunks that I was talking about. And the data chunks in a normal DHT would just go to the computers closest to that address and be stored there. But we don't do that because that would be too straightforward. That's how a DHT would normally work. You've got to have a situation where when you create this system, there can't be any centralized information whatsoever. So there can't be a centralized thing on a computer that says what chunks it's storing or any of this kind of stuff. So that's completely split up. And that's where in Maidsafe with the autonomous network, we have these things called personas. People hear me speaking about ants, you know, this great ant story, but it's very true. Every computer, every vault on the network, every computer has got multiple personas. And what that means is if it gets a message sent to it, it can look at the name of the message and it knows exactly where it came from. And it can say, oh, in this situation, I'm looking after this client machine, or in this situation, I'm looking after this piece of data, or in this situation, I'm looking after the computers who are storing this piece of data. But these personas basically mean that every computer on the network sees its own network. That's how XOR works. Every computer sees a different network from every other computer. But the personas mean that even inside the computer, every persona sees a different network from every other persona on that computer, which makes it a very natural system, a very lifelike system, that the computer or the node will actually adapt itself to exactly the last thing it's been asked to do, and then do that action, and then importantly, forget it. So don't hold state. So there isn't this state held about the network. You don't have things like, oh, that person there sent this bit of information, and because that increases complexity, it gives you security issues. But the autonomous network part is extremely difficult, and it's the most misunderstood part of Maidsafe, because people see DHT and you think, I'll just download the DHT and then I've got Maidsafe. It's nothing like that. It's a very complex thing. But since February, we've found some information out which makes that complex thing much simpler to understand. Although you wouldn't think so when I'm blabbing on like this. Those are the three components. That gives you something that we've never had ever in the world of IT.